Welcome to educator.com. This lesson is about comparing and ordering rational numbers. In this lesson, you'll learn to compare and order rational numbers. So to compare decimals and fractions and to put them in least to greatest or greatest to least order. Applications are, for example, to determine places in a contest or a race, and also to play musical notes. Vocabulary for this lesson includes least common multiple. This means the smallest multiple shared by two or more numbers. And as you can see in the word multiple, it's numbers that you can multiply. It's numbers that you would multiply to become, versus the least common divisor, which are factors or dividing numbers. For example, if you have the number 4 and the number 5, multiples of 4 are 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, and so on. These are multiples. Next, for 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25, and so on. So here we found the least common multiple, which is the one that they have in common, 20. And that's the smallest multiple they have in common. Later on, they also have the multiple 40 in common. However, this one, 20, would be the least, the smallest multiple that they both share. And in this case, the least common denominator is the denominator that can be shared by two fractions. So if you had a 4 and a 5 in the denominator of a fraction, and you wanted to make the denominators the same, the multiple, their least common multiple, would also become their least common denominator. For example, you could say 4 times 5 and 1 times 5 and create an equivalent fraction of 5 over 20. 5 times 4 and 1 times 4 and create an equivalent fraction of 4 over 20. So in this case, it would be easy to compare because since the denominators are the same, you could just compare the numerators and see that the 5 is larger than the 4. So least common multiple is looking at just the numbers, and least common denominator is looking at the numbers in the place of a denominator. Let's try ordering some rational numbers. And I'm going to do this by writing all the numbers as decimals and then showing it on a number line. So this one can stay, this can stay, this can stay as it is, but I do need to change these two numbers into decimals. I'm going to start by doing 2 over 9. So this is going to be a negative 2, 9. It doesn't go in. It'll go into 20 twice. It'll go into 20 twice, and I'm going to have a pattern here. The 20 is going to be repeating. So this is negative 0.2 repeating. Now I'm going to divide 2 by 11. It won't go in. It'll go in once, which will leave me with 9, and 8 will go in. And that will go in once. And so I can already tell that I'm going to have, once again, a repeating decimal. So this one equals 0.18 repeating. Now let's create our number line. I want to have 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And down here I want to have 1, negative 2, negative 3, negative 4, negative 5. All right, so let's put our numbers on the number line. Negative 4 is here. Okay. 0.7 is not quite to 1, but almost. So that's going to go here. 9 is all the way up here. Negative 2/9 is negative 0.2. So that's closer to 0. So I'm going to write it as the original fraction, negative 2 over 9 here. And 2 over 11 is 0.18, not quite to 2. and closer to, not quite to 1 and closer to 0. So this is going to be as the original fraction 2 over 11. So here I've put all the numbers in order on a number line. So by lining them up on the number line, it's very easy to see which one is the smallest, -4. Next, we come to -2/9. Next, we go to 2 over 11ths, then 0.7, and lastly 9. Notice that I am putting the fractions back in their original form, keeping them as fractions, since the problem asked me to write these numbers in order. Now let's try writing all the numbers as fractions. This is 1.5, so I'm going to have to change that because I want it as a fraction. This already is a fraction. This is a fraction, 1 and 2/10. And this already is a fraction, 15 over 5. I'm going to simplify that to a round number 3, an even number 3, an integer. And this can be simplified if I divide by 2 into 1 and 1/5. And this is 1/5 already. And now we just need to rewrite that. So as a fraction, you put the whole number out front, 1, and then 5 over 10, because you have one decimal place, the 5 over a fraction bar, and it's the 10th place value. Now I can divide by 5, divide by 5. I get 1 and 1. 10 over 5 is 2. So 1.5 here. So now let's try and write these all in order. In order to write them all in order, we're going to have to make the denominators the same. Well, first off, I know that there's a whole number, and a whole number. So I know for sure that this is the smallest. So I'm going to write that here. I don't need to change anything. I already know it's the smallest. Next, a half and a fifth. Well, if I were going to make this the 1 and 1/2 and 1 and 1/5 with the same denominators, I could make them both into 10. 2 becomes 10 when I do times 5, so on top it would be 5. 5 becomes 10 when I do times 2, so on top it would be 2. So now it's easy to see that this one is larger, and the 1 and 5/10 is represented by 1.5. So this one would be the smaller one, so that's going to come here, and originally it was written as 1 and 2/10. Next, we said that this one was up, so 1.5, see how it's written originally. And then lastly, the whole number 3, and it was originally written as 15 over 5. Let's come back and check and make sure that we've used all the numbers. 1.5, yes. 1 over 5, yes. 1 and 2/10, yes. And 15 over 5, got it. So there are two ways to order rational numbers. You could make them all into decimals, as we have done with the first problem, or make them all into fractions, as we did with the second problem. Let's compare each pair of numbers. 3 over 4 and 4 over 5 may be difficult to compare because the denominators are not the same. So let's make the denominators the same by finding their common denominator. 4 and 5 can both become 20. 4 times 5 and 3 times 5. So you have 15 over 20. And 5 becomes 20 when you do times 4. So you have 16 over 20. So now it's easy to see that this second one is larger. Now let's try and compare 3 over 11 and 1/6. To think about common denominators, you could always multiply the two denominators with each other. 11 times 6. That will give me 66. 11 times 6, so 3 times 6 is 18. 6 times 11, so 1 times 11 is 11. So now it's easy to see that 18 is larger than 11. So this is our larger fraction. Comparing rational numbers in word problems. A survey found that 13 out of 108 men prefer cookies to French fries, and 23 out of 216 women prefer cookies to French fries. So which group had the greater fraction of people preferring cookies? Is it the men or is it the women? So what we want to do here is to compare these two fractions. What I noticed with 108 and 216 is that 108 is half of 216. So to make the denominators the same, I could just multiply by 2. So now I'm comparing 26 over 216 versus 23 over 216. So it's easy to see that the 26 is larger than the 23. So the men have the greater amount of fraction, have the greater fraction preferring cookies. You could also do this by turning the fractions into decimals. So 13 divided by 108. And that it will not go in to 13, so we're going to put a 0, put a decimal here, and it will go into 130 once. 10 minus 8 is 2. We borrowed, so it's 2. And it'll go into 220 twice, giving us 216. And it won't go into 40 at all, so to be a 0. I'm going to divide here and see if I can stop at the third decimal place for comparison. It won't go into 23, so I create my decimal. It will go in once here. 10 minus 6 is 4, 2 minus 1 is 1. And it won't go in at all here. So I can already tell by looking at this decimal place that the men are larger. So you can compare the fractions by creating the same denominators, or you can compare the fractions by dividing the numerator by the denominator and comparing the decimals. And in both cases, we came up with men being larger. Order the set of numbers from least to greatest. In this case, we're going to use decimals. So that means I'm going to change these two fractions into decimals. To change 1 over 3 into a decimal, you take 1 and divide by 3. It doesn't go in, so create your decimal. It'll go in 3 times. It'll go in 3 times again. And so now I can see that a pattern emerging. It's going to be 3 repeating. So this is 0.3 repeating. Next, for 3/10, 10 won't go in, but it'll go into 30 perfectly 3 times. So it's just a 0.3. 3 repeating is larger because in this second decimal place you have a 3. Here it would be a 0. So now we can compare all the numbers. The smallest would be this one. One good way to do it is to compare each decimal place. We have 0.3333 and so on. Next we have 0.3. Then we have 0.03, then we have 0.33. I haven't put them in order yet. I've just written them out so that we can compare. So in this case, there's a 3 here, there's a 3 here, there's a 0 here, and there's a 3 here. So this one is the smallest, 0.03. I'm going to cross it off my list so I know that I've already used it up. Now let's compare the second decimal place. There's a 3, there's a 0, an imaginary 0, and a 3. So I can tell that this one is the next smallest. And originally it was written as 3 over 10. Next, there's a 3 in the decimal place and a 0 here. So I can tell that this is the next smallest. And that was written as 0.33. And so lastly, the 1/3 is the greatest. So with numbers that are often repeating, such as 0s and 3s, as you can see in these decimals, it's very important to carefully compare only a single decimal place at a time. Order the set of numbers from least to greatest using fractions. So that means I'm going to change this into a fraction and this into a fraction. 7 over 10, because it's 7/10, and 1 and 3/10. So now let's take 1 and 2/5 and 4/9. We need to create common denominators. Straight off, this can become 10 when you do times 2 and times 2, so this will be 1 and 4/10. So now we have a 10, a 10, a 10, and a 9. And we want to create our denominators the same. So I'm just going to make it simple and make them all into 90. So 90 and 10 times 9, so 7 times 9 is 63. Next, 90, keep the whole number out front. 4 times 9 is 36. Next, we have a 1 here. 10 times 9, 90, and 3 times 9, 27. And lastly, times 10, 40, and 90. So I've kept them all in the same order so that I can continue to compare them. So the largest would be the ones with the whole numbers, and 36 is larger than 27. So the largest is 1 and 36 over 90, which was originally written as 1 2/5. Okay, so we're done with this one. Next, we said the 1 and 27 over 90. And that was represented by the 1/3, 1.3. Next, 63 and 40. Yes, the 63 is larger, and that was represented by 0.7. And then lastly, we have 40 over 90, and that was represented by 4/9. So here we've put the numbers, the original numbers, in order from least to greatest by making them all into fractions having the same denominators. Musical notes are based on fractions of a whole note. There's the quarter note, the 16th note, the half note, and the 8th note. Write the notes in order from shortest to longest. So a quarter note would be 1/4, that's a quarter. A 16th note would be 1/16. A half note would be 1/2, and an 8th note would be 1/8. So we have all fractions here, and we want to compare them. We could make all of the denominators into 16. 4 becomes 16 when you multiply by 4. 1/16 already has 16 as a denominator. 2 becomes 16 when you multiply by 8. And 8 times 2 will become 16. So now it's easy to compare. The smallest is the 1/16, the 16th note. Next is 2/16, the 8th note. Next is 4/16, which was the quarter note. And lastly, the largest is the half note, the 8/16. So the shortest note is the 16th, and the longest note is the half note. 2 boxes of candy have the same price. The chocolate candy contains 12 and 9/20 ounces. And the fruit candy, let's say this is the chocolate, and the fruit candy contains 12 and 7/16 ounces. Which candy is the better buy? Well, I need to make the denominators the same so that I can compare. The 12 and the 12 are not going to give me any information here because they are the same. So really what I'm going to be doing is comparing these two fractions, 9/20 and 7/16. Let's find their common denominator. Multiples of 20 are 20, 40, 60, 80, 100, 120. Let's try some of 16 and see if they've met up. 16, 32, 48, 64, 4 is, and then 80. All right, so we have found our LCD 80. Another way to do that is with the factor tree. 4 times 5, 2 times 2, and 5. And here, 4 times 4, 2 times 2, 2 times 2. And you take all the factors that they do not have in common. So for example, 2 and 2, 2 and 2. They have those in common, so I'm going to take only one set of them. And then these are all the ones that they do not have in common. A 5 times 2 times 2 times 2 times 2. These are doubles here, repeats. So that's why I'm crossing these out and only taking this set. So 2 times 2 is 4. 2 times 2 is 4. 5 times 4 is 20, and 20 times 4 is 80. So here there's two different ways. You could list multiples, or you could use the factor trees and find all the factors they do not have in common. So we're going to make both numbers, denominators here, into 80 so that we can compare their numerators. 20 times 4 is 80, so on top, 9 times 4 is 36. 16 times 1, 2, 3, 4, 5 is 80. So on top, 7 times 5 is 35. And as you can see, they're very, very close in fractions. So 36 is larger than 35. So the better buy, if you wanted to have more ounces per cost, is going to be the chocolate. The chocolate is the better buy. Thank you for watching educator.com.